Hey, how's it going, sir? So this is the video for question 3 in the Homeostasis CPT, where I had to draw and explain the process of a nerve having an action potential. So of the membrane of the neuron, you will find ion channels that are closed when the cell is in its resting state. So you'll see here that here's the potassium ion channel, sodium ion channel, and also another sodium ion channel. Then the sodium potassium pump. According to the legend, the yellow circles represent the sodium ions, and the red triangles represent the potassium ions. So you can see here that there is a higher concentration of potassium ions in the intracellular space than in the extracellular space where the sodium ions are dominant. Okay, and the neuron is able to create an action potential because of the concentration difference of ions between the intracellular space and the extracellular space. The extracellular space is more positive than the inside of the neuron. This creates a voltage difference of negative 70 millivolts, which is created by leaky ion channels, which are more permeable to potassium ions than sodium ions. So what that means is that the ion channels allow some ions to leak through, so you can have some potassium ions traveling to the extracellular space, whereas not as many sodium ions would be able to travel inside the intracellular space. Right. And this causes the potassium to leave the cell and only a small amount of sodium to enter. The sodium potassium pump also regulates the environment by pumping out 3 sodium ions and allowing 2 potassium ions to enter. So the negative 70 millivolt is the neuron's resting potential, but when a neuron is stimulated by a presynaptic neuron, it causes sodium channels to open, letting in positive sodium ions. So you can see here that the sodium channel is opened and that the sodium ions are beginning to travel into the intracellular space. This will change the electrical environment and make it more positive inside the neuron and less positive outside. This is called depolarization and results in a chain reaction where the next sodium channels will open, letting in positive ions all the way down the axon. So you can imagine that it would result in this sodium channel opening up. And shortly after they have opened, they will close again. And then after this step, the potassium ion channels will then open, letting out potassium ions to recreate the negative environment inside the neuron and a positive environment outside of the neuron. So you can see here that the difference in potassium ions from this page, or from that step to this step, where a lot of the potassium ions traveled up into the extracellular space due to this the repolarization effect. And this happens at around plus 40 millivolts and causes a repolarization where the intracellular space becomes negative again. The neuron then reaches a state of hyperpolarization where the cell has let out too many ions and has now become more negative than the cell's resting potential, which is minus 70 millivolts. This is quickly corrected by leaky ion channels and the sodium potassium pump. So once again, with the leaky ion channels, here the potassium ions will travel back into the intracellular space, and also the sodium potassium pump will pump out the sodium ions and allow potassium ions to come in, just recreating the original state. And then the neuron will then restabilize at negative 70 millivolts. The action potential that has traveled down the axon reaches the axon terminal where vesicles with neurotransmitters are released out into the synaptic cleft, where the electrical signal will stimulate the next neuron. And that's pretty much it. Thanks.